Okay, so I'm not a huge fan of this particular approach, but um, been recommended more than one time. So I'm just recording a screen session. Well, I'm recording a session towards the end of a session of programming. Say towards the end, it's almost 5 p.m. and I've been here since this morning. Um, writing all this stuff. Uh, what I'm doing, I guess I could do disk checks, but nah, it seems stupid. Anyway, um, I am writing a module that checks a blockchain, the Eternity, specifically the Eternity blockchain, um, for transactions. It's a bad explanation. I back up because nobody who's watching this has any idea what I'm doing at all. I'm making a point of sale system that works through uh, cryptocurrency, but it actually does it on chain live. So instead of using a fake layer 2 or a centralized thing, actually just do the transactions on chain. Now, there's been problems with this type of system before, excuse me, because if you try to do it like on Ethereum, you got to wait forever. And if you try to do it on Bitcoin, you might have to wait, 11 hours if the mempool's really backed up. So for like retail transactions and things, you can't really use crypto, most crypto. There's one blockchain, one that I've been working on for a while. Like I work as a developer in that project because it's pretty solid, called Eternity. And that the technology underlying Eternity itself is the whole trick they've done is they separated the idea of solving a puzzle as a miner from the idea of mining a block. So they have key blocks that come out, and that's the puzzle solution that dictates who the leader is within the distributed blockchain network. And then that leader is kind of not 100% free, but he's free to mine microblocks until somebody else comes along with a better puzzle solution and like unseats him from being the leader. What that allows is that they can mine blocks really quick, and the key block is not it's not a single block that has the puzzle, all the mine transactions, everything inside of it. It's got just the solution, and then there's a separate category of blocks called microblocks. So um, altogether, that's a generation. So in Eternity, a generation is what a single block would be in the older style blockchain. I say older style blockchains, but I mean those are the main blockchains work that this other way, which is like really slow, and it's um it's prone to like transaction eviction and a bunch of other like it gets complicated. Anyway, this works pretty good, and the most important thing about it for kind of like low for small size transactions is that because the throughput's really high, the block reward doesn't have to be massive per transaction, which means that transactions can be cheap while still rewarding miners, which means that the gas fees don't get so outrageous that they're more expensive than the thing that you want to buy. So if you're just, for example, let's say you want to buy a cheeseburger that's $5, well, the gas the gas fees for having any transaction get accepted on the Bitcoin blockchain is like more than that. So it's still you're not going to pay a $10 transaction fee to buy a $5 cheeseburger. That doesn't make any sense. You're also not going to be able to wait for the transaction to come through the Bitcoin network because Bitcoin has a max throughput of like, I don't know, it's like 3.7 or something per second, transactions per second globally. That's not fast enough to run an economy on. So like you could buy a house or a car with Bitcoin, but you can't buy like, a shirt, or you can't do grocery shopping or something with it. With Eternity, we actually can. Um, so that's what I'm doing. I'm building a point of sale system that uses Eternity, and this is part of the back end to it. Not Eternity, this is the back end of the payment system. And what this part is doing is checking um, if there's someone creates a pay issue, and then we have to see if that pay, the expected pay issue, actually pops out on the chain. Now, the whole reason we have to have a back end for this is because if you get paid on a blockchain, you just like get money from somewhere. Now you can look up and see who paid you, or you can at least see what their key is, right? Um, so all money on every blockchain can always, the provenance can always be found by backtracking and see who the sender was. How it, well, at least it's spend transactions. Um, However, when you get paid, you receive funds on a blockchain, you don't, there's no like notation like why that money was sent. Now you could add a note to it, but that's not always done. So what I've done here is ooh, talking too long, screen went crazy. Um, what I've done here is I'm using a QR code to tell a cell phone, a wallet on a cell phone called Superhero. That's like the main, well, it's like the most featureful wallet for Eternity right now is Superhero. Um, the You can show a QR code to that wallet, and that can carry parameters, that can encode parameters that instruct a wallet to create a transaction, a spend transaction to a given address of a given amount. And the feature we added to this was to add a payload. So you can add a text string that will be committed to the chain along with that transaction. So what we can do there is we don't know who the sender is, but we do know who the receiver is, and we know the amount, and we can know a code that we put in there, like a serial number for this particular transaction. And we can try to match up those three things. If we just get paid from somebody, we just got money. But if we have a backend system that knows the receiver, the amount, and the transaction number, in most cases, this should be the real world accounting system serial number of that transaction. Like if you go to a grocery store, you'll usually see like register number 001 and then today's sale from that register 001 or something like that. So you'd have a serial number for the first transaction of the day from register number 1 would be 001-001. Well, that's a text string. And that means we can put that in as a notation into the spend transaction. And so even if every cash register is generating spend transactions to the same key that the company owns, like the grocery store owner, all those transactions can be tracked now because we have the serials from them, so we can match those on the chain and then provide a backend accounting function and say, like people from the grocery store that are logged into either as a cashier, they can see all the transactions they've done today through Eternity, or the store manager can see the store and see all their transactions today and like how the roll-ups work and so on. And the business owners or the business managers, they could look in and see company-wide, like how do we do today? That's the goal here, is to provide that kind of functionality as opposed to just the transactions that you can do with a phone or whatever. And that retail has been the overlooked place. That's the thing that crypto can't do right now, is retail. So I'm trying to make like a retail system to track this. Not the most exciting code in the world, not the most exciting use case in the world, but it is the use case where everybody's got a, everyone does this. Everyone goes shopping. Crypto's cool as a Ponzi scheme, right? But what can you buy with it? Well, you can't really buy a whole lot because there's no marketplaces that use crypto. Now, I wrote a marketplace that uses crypto over here. This thing was the testnet one, but this is a functioning marketplace. Like if I wanted to buy this waffle maker, I could like order that with the buy button and go through the whole purchase process. Except I don't have money in the wallet on this I'm not logged into the account that's got the money, so I can't do it. But this is a real marketplace where you really can buy stuff, right? Um, as far as I know, this is like the only one that works like a just a normal, like family friendly, ordinary sell stuff to people, person to person marketplace around like anywhere. Um, so this is its native skin. Anyway, um, so I'm trying to do something kind of like that, but just for uh, anybody who has a small business and wants to be able to accept Eternity token, well, crypto, right? And then inside of an exchange or whatever, you could switch things around and like buy Bitcoin with your Eternity tokens or like whatever USDT, and then buy dollars with it or buy yen with it or buy euros or whatever it is that you want to do with your money. The whole point of paying is that we don't have a back end like ordinary, boring, old fashioned kind of accounting system tie into crypto. Um, so businesses can't really use it. They're like, oh, crypto, that sounds neat. How can I accept this in my business? And then once they find out how much of a circus that is, they go, okay, never mind. Um, that sounds neat, but like, what can you do with it? It's kind of stupid. So I'm trying to reduce that retardation right now. Okay, issues here. What's happening is this the interface. Where's track? No, this okay. So track is a function. It's an interface function that's exposed. It sends a message shaped like this: track issue and then time to live, um, which is matched by this cast thing here. A handle cast will get track. So this is an asynchronous. Throwing this message out into the wild. Go, look at that. Um, and so do track. That's where we get here. So we get the do track function. Um, so issues are pay record. Whoa, not like that. Like that. Pay records. They have IDs. Okay. Right. Okay. And you forget issue. So I'm gonna have to have. I've got this time to live thing, and I don't have any way to track that right now because I didn't do that yet. So we're gonna start out not knowing anything. What type should this be? This is gonna be what? Well, the TTL. And the page. That's the main module name of this project, page. Page is short for pay.agora.jp. So the site that I just showed you, which runs in this network, so I don't have like the external URL for it here. Agora.jp, that's like the public marketplace where you can like sell stuff online to each other. It's like eBay, but crypto. It's eBay, but it's crypto, and it doesn't, or it's based on crypto. The sales transactions occur in crypto through a smart contract, and it's not an auction. It's just like you want to buy a thing. This is how much we're selling it for, and once you decide you want to buy something, you and the seller, the buyer and the seller, whichever one you are, because you could be either side. There's no like registration, it's really lightweight. Um, the buyer and the seller can negotiate the price. Like the sale issue itself goes away from the public view, so like it goes into negotiation mode, and because we know that the price of crypto is going to like fluctuate and go all crazy, so um, the once you like you want to buy a thing, you do buy, and the next step is you commit your funds to the smart contract for the item to buy the thing. So if you want to buy something, you can't just say you want to buy it and then like make their stuff invisible to the world. You actually have to pay like the money into the contract to prove that you have it first, and then you get refunded if you roll it back. But anyway, put money in the contract. That changes things for the seller. So the seller now sees that they've got a buyer, and that page, the item page itself, the sale item page itself, turns into like kind of a chat window. So you can, well, these are like a forums. If you want to see the next, refresh the screen, it'll show you the next thing or whatever. Um, anyway, you can type messages back and forth to each other, and from that sale item issue, if you're the buyer, you can block the sale, which locks the contract temporarily, so they can't just take your money out of it. Um, if you want to negotiate the price, like I want to buy this, but it's too expensive. I want to negotiate the price or whatever, so you can negotiate that price down with the seller. You know, tell them where you want to send it and all that stuff. So have that conversation there between the buyer and the seller directly. We're not like involved in that. And then that's it. It's, transaction's done. Guy sends you the thing. You give them a sale review. There's a sale review thing at the end of the transaction. At the end of the whole like sale process. Anyway, uh, that is agora.jp. This is called Page, and that's short for pay.agora.jp, which is the intended URL of this project once it's like actually up, but we're not there yet. So anyway, pay ID, integers. I think I'm gonna make like a type declaration so I know what this actually is. Now this is a note from my. I'm not even gonna run the type declaration, because I don't care. The reason I don't care is because these notations are actually for me to force me to like think through this. And that's just part of how I work. Not everybody likes that or does that or whatever. Um, some people, I like types on interface functions. I don't really care for them so much inside of the do stuff code unless it's pure. Even then, it's distracting. Anyway, so we want to track this thing. Now we got a TTY, and in this state record we have those. Okay, and so I'm gonna put oh well, first I want to check, right? Wait, it's key member? This should be key member. Element, make sure that, no, element 2. Make sure element 2 of the list. Yeah, so we want to make sure that that's not already. Okay, if it is a member, this is the easy shortcut case. We're not going to pay attention to it. We're just going to return that back. Okay. If it is not a member, then we're not tracking it, and we want to start tracking it. So we're going to go with, what's a good? I feel like I should. So like this is a list traverse. See, I'm thinking already about optimization. It's kind of stupid. This list of like the traversing the whole list of issues we might be tracking. At most, we have like a couple thousand. That's nothing. Like, it's really nothing. Probably just have like dozens at the most ever. And list traversal, I mean, traversing a string is the same. And we do that all the time. And it's like, I, computers are so fast, it's just not that big of a deal. But I'm already thinking, oh, I could do a combined operation. I could do a deep traversal through all the TTLs and I could find the point at which that I could break at the point that the old transactions are dead and use the tail as my uh, cleanup list and snip it off right there, which I could totally do. Oh, it's tempting to. Man, it's tempting to. I'll probably wind up doing that because I'm just a huge gooberhead. So, anyway, I'm take a timestamp. So, not wage, page. Timestamps in this project are like, I think nanosecond timestamps. Um, it's just a big energy. It's like the Unix timestamps. It's just they're like huge numbers. And that's that. Let's see. So I'm gonna need a then, which is gonna be now plus let's do it. Yeah, sure. Do I like that? The idea being, how long do I want this to live? And then don't make the caller calculate that ahead of time. That's probably a good, yeah, that's probably fun. Okay, so actually, it's not even positive energy. What this is, I type for this. Called a page timestamp. Okay. Which is easy enough to just, easy enough to note right there. Once don't need that type anymore. Neat. Okay. Yeah. So right. It's in there. Yeah. Okay. Do track. I'm gonna jump down to the next layer, which will be issue. Yes, I'll go ahead and put in there now. Then the ID. See, so stacking them up this way will make it so that the list is ordered. So newer ones are always on the front, which means that if I do traverse that list and go down, I can always find a point at which the front part is still fresh, not expired, and everything after it is not, and it's really easy to break up then. It's not the most efficient. It'd be more efficient if I reversed it, but the act of reversal requires a traversal and a rebuild, right? So, like, it's not that big of a deal right now. So, track issue, and then I'm going to go ahead and pat the state with the new thing. Okay. Expecting. Okay, so I typed that expect. I guess we'll do it. So, I'm gonna find assuming that I find the guy, which probably won't happen actually, because these things clear so fast. The base case is almost always going to be false. Or no, error. That fucking turns error. if it's not present. Um, what was it? It's just a list of paid things. So if it's not in there, new expecting is going to be maps put oh wait, it's going to be a list. So I need to make that a list of issues, right? Okay, but it's just got one thing in it. Put that in the expecting map, and then the return is going to be, and that's done. Okay, and so if I do have waiting, then new expecting. Actually, so in both case, what I'm doing right now is I'm reducing code a little bit because I know it's coming. In both cases here, I've got I'm going to be rewriting maps put this and with like a single list. And there's a maps function to make this easy called like update with or whatever. But this is so simple. I'm not explaining that very well. Okay, so in both cases, I'm going to have to do this, right? So maps put it. If I can type today, okay. Look at me. Okay, maps put recipient, and then it would be issue, and then waiting, like that, right? And then I would do state, and the state record get propagated back up. And in both cases, I'd have state expecting you wait. Like these lines, I could like copy paste this line, right? Just turn the semicolon off the end. That's kind of dumb because what I actually care about here is the waiting, like this waiting element that's being stored into the expecting thing. That list, that's the only thing that looks any different between these two. So just ahead of time, I'm doing this like that. Okay. And then delete these. Actually, don't need to multi-line that because it's silliness. Okay. Now, I know a lot of people don't care about alignment of code, but for me, this is for me when I come back and read this later. It's easier for me to read in this kind of like specific visual idiom that I've got. Okay. Now, this is not the same thing as dry. Don't repeat yourself. Right, same thing twice. I'm just collapsing this down so that like later when I come back and read this and something's wrong with it, I'll be able to identify exactly what I found here like really quick because it's obvious. There's only one thing in here. Instead of kind of visually processing all this code, like, six, 8 lines, whatever, and going, oh, wait, there's only one thing that actually changes in here, and that's the waiting thing. That's stupid. The list changes. There's something being appended to a list. That's all that's happening here. Whereas here, it's like really, really obvious. If I see these two shapes, that's why I like the alignment too, because this arrow and that arrow. To the right of it, I see a list of one item, and then on this one, I see a list that's being added to. And it's very visually distinct, and I like that. Not everybody likes that because a lot of people are dumb, and dumb people like to make super crazy leet code and make it confusing for themselves and have everything all scattered everywhere because that's the aesthetic that, well, they don't understand that there's such a thing as code aesthetic and that it matters. So anyway, those dumb people aren't my problem. Put recipient, new waiting. Okay, so expecting is a map. We're up. This is like an upsert. So if you already had an element with this key, it'll replace the value with this thing. And if not, then it'll enter it into the map. So, and that's it. So expecting equals new expecting. Now, why don't I just put this here? Well, sometimes I do. But again, being really, really visually distinct from a future self. That's why I'm giving it a label. And this language, you might go, but the memory allocation. No. In this particular language, there are no, you can't update an assigned variable. So these are like variables in an algebra class, where once you've given it a value, that's its value forever. And you cannot change that value. So the equal sign is an assertion and an assignment. So that's why I called this a label. It's not really a variable. I gave it a name, but at compute time, it's zero cost. Like this, when the compiler goes over this, this all disappears. This code is just for my eyes, and that's it. So anyway, so do track 2. We're going to go ahead and put that in there. We checked the ID, which is unique across this entire system. So that's an easy way to figure out if we already had that one there. Okay, and that's that. So do forget is going to take the issue. You'd start roughly the same way. And we'll start with the, because it needs to be removed from both. So do forget. Okay. I don't do a full list comparison because it's silly. Yeah, okay. This'll tell me if the thing came back or not. I've already got the issue. I don't need to see the ID again. But yeah, but this'll give me what I want to see. List key take ID two of the things in this list. No, it's not. Wait, yeah, it is. Yeah, it is. Yeah, I'm stupid. Yes, it's the ID. It's element number 2 of the things in this list. I forgot that looks like in here. This is how I learn things, how I remember things. Key take. Yeah, key. Okay, tuple list. Yeah, blah. False. That's what I'm looking for. Value tuple list 2. Okay, I don't actually care what this thing looks like. I just care that it's been evicted. And this is going to be the remaining ones. Yeah. Cool. Oh, no. I actually need the whole list because I need like the guy that's addressed to because I have to look through the thing. We're going to proceed with those. Also doesn't. That's so false is going to be my return. And, okay. I don't ever need this thing again. ID. Okay. So what has to happen? Ooh, what am I doing? Can't type Moonspeak in here. Confuse people. I got to maps find. Yeah. If I'm this far, like, I would normally even just assert this as a match, but I'm doing a case here just in case because I want to find out if I have a bug or not. Um, Actually, no, I'm not gonna. I don't give a shit. Um, Actually, I can do map get, I think, because it should crash if it can't find the thing. I rarely um, use maps get because of this. So I'm just making sure how it works. I think it's maps get. No map. Oh, I'm stupid. I'm not in maps. That's why I can't find get. Get. Yeah. Okay. Key. Yeah. There we go. Right. So that'll crash. This will crash actually if the thing I'm looking for is not in there. And that's what I want because if this should blow up. There should be no possible way for me to not have the thing in the expecting dictionary if that ID is in the TTLs, right? So, um, yeah, cool. Lists. I think it's key delete. Okay, now I need a match. Case of most cases it's going to be like that. Nope, this is going to be a complete different thing. Okay. Okay, what this is going to be when I key delete that, um, what will happen is that user or that whatever that recipient no longer is waiting. Like that would be if I remove that waiting thing and it's the last one, then I'll have to get an empty list back. If that list is empty, then that recipient's not waiting on anything else anymore in the system. So I'm going to remove that recipient from the expecting thingy. And otherwise, so this is the new expecting. So we're going to remove them from the expecting list. And so the new expecting is going to be expecting dictionary with whatever expecting map with them gone. Um, Otherwise, it's going to be the shortened list of issues. Um, and so state is going to become, because we already added, as we passed state through here, we already got the TTLs like were updated. So that's updated. And so that's that. Yeah. Okay, so that also means that when we hit a TTL, when we hit a group, whenever we do our checks, which I haven't decided yet when um, when the system is going to check TTLs. But basically, whenever that happens, I'm going to wind up with like a a routine to go through and clean these out, which means recipient maybe. So the quick way to do that would probably be to keep track of the recipient, because when the TTLs come up, I've only got the pay issue ID, right? Well, actually, let me make sure. I think I can actually look those up just with the ID. And if I can, then I can just, yeah, I can. Look at that. Look at that. Oh, shit. Okay, so I can find out. All right, so that's discoverable. So like as a final, I could do is like a final step to check. I could scrub TTLs, right?